Hi students, problem number 7. The time period for small vertical oscillations of a block of mass m, where the masses of the pulleys are negligible and the spring constants k1 and k2 is to be determined. So now the problem statement is very small, but understanding and solving the problem requires much involvement. Understanding is required first. Now let us take this is the mass m. Now this mass is attached by a string. That string is passing over two pulleys. Okay, subsequently two pulleys, and it is attached here from the ceiling. There are two springs whose spring constants are k1 and k2. Now, if I will pull this mass in the downward direction through a displacement x, what will happen when I pull the mass and release it? The system is going to oscillate. Okay, so it will have a time period, and what is its time period should be any one of the four options. We have to find out that. Okay, now when I will pull this mass m through a distance and release, the system is going to accelerate. Okay, so the tension in the string, above this mass is T. Therefore, I will write the tension T is equal to the mass attached into its acceleration. Okay, so this is the first root equation. So there is only one string above this mass and only one tension above this mass. That tension must be equal to this mass into its acceleration. So this is equation 1. Okay, next, when I pull the load in the downward direction, these two springs will be stretched. Is it not? You can see here all these pulleys and the springs and the mass all are connected with each other. So once if I will disturb the system by pulling this mass will pull the spring in the downward direction. So the second spring of constant k2 will be pulled in the downward direction. The spring will expand. It will be stretched. So let us take that it is stretched by a distance x2 or displacement x2. The spring is expanding. Okay. At the same time, when the spring is expanding, what will happen to the position of this pulley? The pulley number 2 will also move down, because the spring is expanding by a factor x2. So now this spring also is expanding by x2 and the pulley also is moving down by the same value x2 in the downward direction. So the pulley is stretched down along with the spring. Who is also moving is the pulley. Okay, so the distance moved is x2. Okay, now who is passing over the pulley is the string. So the string is passing over the pulley. So how much length of the string is going to extend is, the pulley is moving down through a distance x2, but over the pulley upward one x2 and downward one x2 will be the length of the string, which is going to increase. Is it not? So here x2 plus x2, 2x2 will be the extension of the string or the thread which is passing over the pulley. Okay, that will be added in the downward displacement of the mass. Similarly, when we pull this load in the downward direction, the first pulley 1 will be stretched along with the spring of constant k1. So in the spring k1, an extension x1 is being produced in the upward direction. X2 is in the downward direction and x1 is in the upward direction. So when the spring is stretched by a value x1, the pulley 1 also will be moving through the same distance x1 in the upward direction. As a result, how much length of the string is going to elongate is this left side one x1 and right side another x1. So the pulley is moving to a new position, okay, through a distance x1. But the string passing over the pulley is extended by 2x1. Here we explained like 2x2, isn't it? When the pulley is here moving downward through a distance x2, the length of the string passing over the pulley is extended by 2x2. Similarly, when the pulley 1 is moving in the upward direction through a distance x1, the length of the string or the length of the thread passing over the pulley is extended by 2x1. Isn't it? That means what? Here, this extension produced by the string, okay, or the mass is moving through a distance x. This must be equal to what? 2x1 plus 2x2. Understanding this concept requires a concentration. So you think when the spring is tied, when the spring is attached to the pulley, how much displacement the spring undergoes will be the same as that of the pulley. So here the spring K2 is pulled in the downward direction and it is extended through x2. So this pulley number 2 also is moving down through a distance x2. But the length of the string passing over the pulley is extended by 2x2. Similarly, here the spring K1 is being pulled in the upward direction. It is stretched through x1. So the pulley 1 also is moving above its original position by x1. But the length of the string which is passing over the pulley 1 will be extended by 2x1. So I will write here, students, x is equal to 2 times x1 plus 2 times x2. So this is very, very important equation. So equation 2 is the net displacement of this load m in the downward direction is equal to what? X is equal to 2x1 plus 2x2. Only the magnitude I have substituted. Okay, now you see here this spring of constant K1 and K2 are stretched. Is it not stretched? So what will be the restoring force acting on the two springs? So first I will write for the first spring here. For the first spring I will write, okay, for the first spring, the restoring force magnitude I am writing, only the magnitude I am writing. So K1 into x1. So restoring force is equal to what? K1 into x1. Okay, now you see here how many strings are pulling this first pulley upwards. The first pulley and the spring are being stretched in the upward direction by how many forces? Two forces. Tension is acting on the two strings. T plus T is 2T. So F must be equal to what? 2T, is it not? So both the strings are pulling, okay, are stretching the pulley in the upward direction. Along with that, spring also is being pulled by the same two forces, T on left side and T on the right side string. So what is the net force acting on the pulley as well as the spring? That is equal to 2T. So the restoring force I am going to write here as 2T, okay. 2T is equal to K1 times x1. K1 times x1. Therefore, what is x1 is equal to 2T divided by K1. And this is our equation 3. Okay, children, now you look at the pulley number 2. So on both sides of the pulley there are two strings. Once again, these two tension forces are pulling down, okay. As a result, the extension x2 is produced in the second spring. So I will write for the second spring. For the second spring, I will write another similar equation like this. The restoring force F, okay. Restoring force. If you want, I can write here F1 and here F2 just for a distinction, okay. So F2 must be equal to what? The extension is x2 and spring constant is K2. So this must be equal to K2 into x2. Similarly, here also the restoring force is what? T plus T is 2T. So 2T is equal to what? K2 into x2. Therefore, what is x2? That is equal to 2T divided by K2. 2T divided by K2, and this is our equation 4. Now what is the net displacement of the load The mass m is displaced through x. So what is x equal to 2x1 plus 2x2? I am going to substitute for x1 and x2 in equation 2. Okay. So net displacement, the net displacement of the mass m is given by x is equal to 2x1 plus 2x2. So this is 2 into x1 plus x2. So this is equal to 2 into 2t by k1 plus 2t by k2. So this is 2t by k1 plus 2t by k2. So that when I take this 2t factor outside, 2 into 2t will become what? 4t. So this is 4t into 1 by k1 plus 1 by k2. Okay. But from equation, what is the tension T is also equal to m into A, is it not? So in place of tension T, what also can be substituted is m into A. So I can write x is now equal to 4m into A. So 4ma into, now if I take the LCM, this will become k1 plus k2 by k1 k2. So this is k1 plus k2 divided by k1 into k2. So we need an expression for acceleration. So get an expression for acceleration. Take a on the left side. So that a will be equal to what? X divided by 4m into reciprocal will come. Is it not? So I want to take an expression for acceleration. So acceleration is equal to x divided by 4m. So this is x divided by 4m into k1 k2 by k1 plus k2. Reciprocal will come. So here this is a k1 k2 divided by k1 plus k2. So this is equal to 1 divided by 4m into k1 k2 divided by k1 plus k2 into x. This is our equation number 5. From the definition of a simple harmonic motion, we can also write a is equal to omega square times x. The negative sign is neglected because we equate only the magnitude. So this will be the equation number 6. This is from a definition. Okay, definition of SHM. Okay, now I am going to compare the equations 5 and 6. Left hand sides are same, so right hand side. So you see here omega square into x. So omega square into x, this is equal to 1 by 4m into k1 k2 divided by k1 plus k2 into x. Okay. So now I can cancel the x term on both sides. So omega square is equal to 1 by 4m into k1 k2 by k1 plus k2, or omega is equal to square root of 1 by 4m into k1 k2 divided by k1 plus k2. Therefore, period, okay, therefore, period t is equal to 2 pi divided by omega. 2 pi divided by omega. So, 2 pi is retained and the reciprocal of omega I am going to write here. So that this is now equal to 2 pi into square root of omega is in the denominator, students. So, here omega, what is the terms on the numerator and denominator, we can take the reciprocal and write. So this 4m is going to the numerator, okay, into k1 plus k2 divided by k1 k2. So this is the expression. Now this inside the square root 1 4 term is there. So when you take this 4 out of the square root, it will come as 2. So t is now equal to 2 pi into 2 into square root of m will be remaining. M will be remaining. So what is this k1 plus k2 whole divided by k1 k2? How I am writing, you see here. So this is K1 divided by K1 K2 plus K2 divided by K1 K2 inside the square root. So that here K1 and K1 get cancelled, here K2 and K2 get cancelled, so that 1 by K1 plus 1 by K2 will be remaining, is it not? Therefore now T is equal to, this 2 into 2 will become 4 into pi into square root of m is retained into 1 by K2 plus 1 by K1 also can be written as 1 by K1 plus 1 by K2. This is the required expression for the time period of oscillation of this load m in this system. So which of the options will be correct? Let us see. So option A is 4 pi into square root m into 1 by K1 plus 1 by K2. So option A itself is the correct answer. Okay. Therefore, option A is the correct answer. This type of problems, I don't know, many examples can be taken. Here 2 springs and 2 pulleys are given. 3 springs and 2 pulleys. 1 spring and 1 pulley. Generally, this type of problem come under the IIT and NEET preparation under what title? Means spring constraints or spring, pulley and mass system. You will have to search okay, the title what? Spring, pulley, mass system. So varieties of problems if you do means then you will get a correct knowledge of how to approach a particular example. See, such problems can also be solved by using the principle of conservation of energy also. That in the next video we will see. I hope you must have understood this well. Fine.